This lesson continues our exploration of composing trig functions and inverse trig functions. So let's just start with a review of what we've already covered. So if I asked you for the sign of the arcsine of 2/3, hopefully you recall that if the trig function sine is on the outside and the inverse trig function, in this case arcsine, is on the inside, then you pretty much know that the answer is going to be that argument 2/3. Because if you think about what this statement means, arcsine of 2/3 means find the angle, and it has to be in quadrant 1 or 2, because that's where arcsine answers are. Find the angle with a sine of 2/3. I don't know where it is, but it's some angle, and its sine is 2/3. And then I'm asked to take the sine of that angle. Well, of course, I'm going to get 2/3. If the inverse trig function is on the outside, in this case arc cosine, and the trig function, in this case cosine, is on the inside, you do have to think a little bit more carefully. Since pi over 8 is positive, we're in the first quadrant, it's a pretty safe bet that the answer will be pi over 8, but I would like to just draw a picture to think about this a little bit. So the cosine of pi over 8, well, I don't have that memorized, but pi over 8 is probably about right there somewhere, and it has some cosine. And then if you take the arc cosine, that means you're looking for the angle in either quadrant 1 or 2 that has that cosine. Well, it has to be pi over 8. And in general, if you're in the first quadrant, then the answer is going to be contained within the problem. It's only when you are outside of the first quadrant that you need to be extra careful about the answer maybe not being so obvious. Now we're going to look at what I'm calling mixing and matching, because you'll notice in this example the outer function is cosine and the inner function isn't arc cosine, it's arc tangent. So there's more than one way to figure this out, but what your book shows and what I'm going to do is actually go back to right triangle trig, and I'm just going to draw a picture. I'm just going to draw some right triangle. And I'm not worrying about being to scale here, and I'm going to mark this angle theta, and I'm going to force this angle to have a tangent of 4/3. Remember, tangent is opposite over adjacent. Now clearly this picture is not drawn to scale. If that's bothering you, let's just do that again and make it a little bit more to scale. So we want an opposite side of 4 and an adjacent side of 3. So let's do it a little bit more like that. That's a little more accurate. So here's my angle. I'm just going to call it theta. I'm going to force its tangent to be 4/3 by putting a 4 here and a 3 there. Then I'm going to use the Pythagorean theorem to find the hypotenuse. Well, c squared in this case would have to be 4 squared plus 3 squared. C squared has to be 16 plus 9, or 25. And so C, the hypotenuse, has to be 5. Once you've constructed that triangle, you now just take the cosine of theta. And remember, cosine is adjacent over hypotenuse. So in this case, 3/5. So again, the way you can figure these out when it's mix and match is to draw a right triangle and force the angle to have the tangent, in this case, of 4/3. Find the missing side using the Pythagorean theorem, and then once you have all 3 sides of the triangle, you should be able to find any trig function for that angle. For your homework, I want you to work problems 36 through 42 out of your textbook on page 180. The first couple are very much like the example in this video. When you get to number 39, I'm giving you a hint. because it might not be immediately obvious what you need to do. You're going to have to use the formula that you see here. We've used that formula in the past to find exact values, and now you'll be using that formula again in a slightly different context. Please have that ready for class next time.